हेलो एवरीवन। आज हमें इस वीडियो लेक्चर में हाइड्रोजन बॉन्ड के बारे में डिस्कस करेंगे। सो वी आर गोइंग टू फोकस ऑन a particular type of bond which is known as hydrogen bond. Now, as the name suggests, this bond must be present in those compounds containing hydrogen only. So in reality, this is not actual chemical bond, but it's a dipole-dipole type interaction in molecules containing a hydrogen atom, which is attached to a strongly electronegative atoms like oxygen, nitrogen, fluorine. Means already the hydrogen is covalently bonded to an electronegative atom, and this hydrogen is sandwiched between two electronegative atoms. So that hydrogen forms an intermolecular attraction between the another electronegative atom. That electrostatic force of attraction is known as hydrogen bond. So look at it, this since this being not an actual covalent bond, the strength of hydrogen bond is always weaker than the normal covalent bond. So the heading is hydrogen bond. So coming to the definition part, it is a bond. So let's not use the word bond. A dipole interaction in which hydrogen atom is sandwiched between two electronegative atoms So already the hydrogen is covalently bonded to another electronegative atom, and that hydrogen is sandwiched between two electronegative atoms. So that hydrogen forms a dipole-dipole type interaction, which is known as hydrogen bond. So as I told you, it is not an actual chemical bond. Actual chemical bond. So since this being not an actual chemical bond, the strength of hydrogen bond is always less than normal covalent bond. So when we compare the strength of hydrogen bond and a normal covalent bond involving hydrogen, then covalent bond strength is always stronger, much stronger than the hydrogen bond. Now, so this is hydrogen bond. Now look at this. These hydrogen bond formation requires certain conditions, and if these conditions are not satisfied, then there is no possibility of hydrogen bond. So What are the necessary conditions required? Look at this. Conditions required for hydrogen bond formation. So the first condition is these hydrogen must be covalently bonded to an electronegative atom like nitrogen, fluorine and oxygen. Hydrogen must be covalently bonded to an electronegative atom, so highly electronegative atom like nitrogen, oxygen and fluorine. So these conditions must be satisfied. Second condition is these hydrogen which is covalently bonded to an electronegative atom must be sandwiched between two electronegative atoms. Hydrogen must be sandwiched between two electronegative atoms like nitrogen, oxygen, fluorine. Third, the other electronegative atom जिसमें हाइड्रोजन बॉन्ड बनाना है should contain at least one lone pair electron. The other electronegative atom to which hydrogen bond is to be formed must contain at least one lone pair electron. So if these three conditions is satisfied, then only we can have a hydrogen bond. So every hydrogen cannot involve in hydrogen bond. So for this hydrogen to be involved in hydrogen bond, the requirement is these hydrogen should be bonded to a strongly electronegative atoms like oxygen, nitrogen and fluorine. So if this hydrogen is covalently bonded to a strongly electronegative atom, then the polarization of this bond will be maximum. As the polarization is maximum, hydrogen will acquire positively polarized character, and that hydrogen which is electron deficient will involve with another electronegative atom having lone pair electron through its electron, and that forms a dipole-dipole interaction, and this interaction is what we call as hydrogen bond. So suppose we have this example, look at this. Look at this. I'm just taking OH bond. So look at this OH bond. This OH bond, oxygen is electronegative, hydrogen is less electronegative. So because of this oxygen acquires partial negative and hydrogen acquires partial positive. So we have a dipole developed. So this dipole should be large. This is the reason why this should be covalently bonded to strongly electronegative atom. So we have first condition, hydrogen bonded to a strongly electronegative atom, so that this bond is much more polarized. Now take another OH. So look at this, we have this hydrogen covalently bonded to electronegative atom, and this hydrogen is between two electronegative atom. Again look at this, negatively polarized, positively polarized. So these hydrogen, positively polarized hydrogen interacts with negatively polarized electronegative atom O through a bond which is known as hydrogen bond. So this bond, which is not actual chemical bond but is a dipole-dipole interaction, this is what we call as hydrogen bond. Similarly, we can also have look at this OH and look at this F minus. This is electronegative atom, so these polarize as such, and this is a very strong electronegative atom, so this hydrogen is sandwiched between two electronegative atoms, so this forms a hydrogen bond. Similarly, look at this, we can also have look at this, take this NH, same polarization here. Again, look at this, nitrogen being more electronegative, we can have this polarization. So hydrogen sandwiched between two electronegative atoms, so these forms hydrogen bond. So that means this is what we call as dipole-dipole interaction, not actual chemical bond that is being formed. So this is what we call as hydrogen bond, and these three conditions must be satisfied. Now, this hydrogen bond is of two types of hydrogen bond. So hydrogen bond is of two types. We have intramolecular hydrogen bond and intermolecular hydrogen bond. So we have intramolecular and intermolecular hydrogen bond. So let's take up one by one here. First, let's take up intramolecular. Intramolecular hydrogen bond. Now, as the name suggests, intramolecular hydrogen means within the same molecule. We are having a single molecule, and in this single molecule there is a hydrogen bond. Means all three conditions required for hydrogen bond formation is present in the same molecule. So if hydrogen bond is present in or within the same molecule, then this is what we call as intramolecular hydrogen bond. So definition: hydrogen bond present within the same molecule, single molecule में hydrogen bond present है. This hydrogen bond is known as intramolecular hydrogen bond. Let's take out some examples, then will be clear. So we have this example: ortho nitrophenol. So this is ortho compound NO2OH. 1,2 position is known as ortho. Benzene with OH is known as phenol. We have a nitro group and phenolic group at 1,2 position is known as ortho. So we have look at this. So first condition is we have an oxygen through which hydrogen is covalently bonded. So the first condition is satisfied, hydrogen bonded to a strong electronegative atom. Second, this hydrogen must be sandwiched between two electronegative atoms. So the second condition is again satisfied. So this hydrogen is polarized negative, this is positive. We have looked at this nitrogen oxygen, so oxygen is more polarized here. So this oxygen is having 2 lone pair. So this forms hydrogen bond. Or we can also have this. Same, we have same polarization here. So this is negatively polarized. We have electron. This is negatively polarized. This is positively polarized. So there is a dipole-dipole interaction. We can also have this ortho dihydroxy benzene. So again look at this, we have two OH group present in ortho position. So we can have this or both are possible. So we have look at this. This is polarized. This oxygen having 2 lone pair is negatively polarized. This is positively polarized. So these forms intramolecular hydrogen bond. Same here. So this is intramolecular hydrogen bond. Ortho salicyldehyde. We have this CHO aldehyde group, OH group. So we have this structure. This is now this hydrogen which is bonded to carbon cannot involve in hydrogen bond because the first condition is not satisfied. Hydrogen carbon is not a very strong electronegative atom, so hydrogen bonded to carbon cannot involve in hydrogen bond. So similarly we can have ortho salicylic acid COOH and OH. So we have this. Or we can have this. In both cases we have, so hydrogen of acidic group as well as hydrogen of OH group both can be involved in hydrogen bond, negative, positive. So this is negative, this is positive, hydrogen bond. Same here, this is negative, we have 2 electrons here. So we have this. So this is some of the examples of intramolecular hydrogen bond, and I'll take a very important point here. So we have this chloral hydrate, chloral dihydrate. This is CCl3CHOH OH. This is chloral dihydrate and the structure is C, Cl, Cl, Cl. We have this. This is chloral hydrate. So the first condition is hydrogen bonded to electronegative atom. So we have a polarization here. So this hydrogen is centered within two electronegative atoms, though hydrogen bond involving chlorine is less due to less electronegative nature and the larger size, but still chlorine can also participate in hydrogen bond. So there is hydrogen bond here. This is negatively polarized, this is also negatively polarized. Similarly, in some of the compounds, look at this. You can have a look at this. PHCOH, COH, OH. These type of compounds, these hydrogen can also involve in hydrogen bond stressing. Let's make it a bit clear. So we have this. Negative, positive, hydrogen bonding. This is having lone pair electron, this is positively polarized, negatively polarized. We have this hydrogen bond. So this is how intramolecular hydrogen bond is formed. So in this, within the same molecule, all the three conditions required for formation of hydrogen bond is present, and this forms an intramolecular hydrogen bond. So the other type of hydrogen bond is intermolecular hydrogen bond. So next is intermolecular hydrogen bond. So as the name suggests, this hydrogen bond is present between two different molecules or two same molecules of different compound. So two molecules के बीच में अगर hydrogen bond है, then we say this is intermolecular hydrogen bond. So formed between two molecules. So these two molecules may be different or may be same, but this is between two molecules. This is known as intermolecular hydrogen bond. So we will take up example. Hydrogen bond in liquid water, we say water is liquid because of formation of hydrogen bond. So let's look at this. We have this. So all the three conditions required for hydrogen bond formation is present here. We have this polarization, look at this, negative, positive. This is having lone pair electron, positive, negative, negative, positive, positively polarized. So this forms hydrogen bond. So if you look at this is between two different molecules of water. So these we say intermolecular. Similarly, we can have hydrogen bond here. We can also have hydrogen bond. So water is liquid because of this being involved in intermolecular hydrogen. Because of this intermolecular hydrogen bond, the boiling point of water is 100 degrees centigrade. The high boiling point of water is because of this intermolecular hydrogen bond. Now in solid, H2O solid, that is ice, these water molecule, a single water molecule can involve in a maximum of 4 hydrogen bond. So we have looked at this state of this water molecule. Single molecule of water So we have look at this, take this water molecule, we have electron pairs, this is negatively polarized, this is positively polarized. This is positive. Now look at this hydrogen which is bonded to oxygen is sandwiched between two oxygens, so these forms intermolecular hydrogen bonds. Same here. So a single molecule of water can form a maximum of 4 hydrogen bonds. So please keep in mind, a single molecule of water can form a maximum of 4 hydrogen bonds. So look at this, when this forms 4 hydrogen bond, a large occupied space is formed. That means when we go to the crystal structure, this is something like a case-like structure. Because of this case-like structure, a large unoccupied volume is present. Due to the presence of this large unoccupied structure, the density of ice is always less than the density of liquid water. So this is the reason why ice floats on the surface of liquid. So we have looked at this case like structure having large unoccupied space or volume is formed, and this leads to density of ice being less than density of liquid water. So this is why density of ice is less than density of water. If you heat ice will melt. Melting of ice means this hydrogen bond will break. As the hydrogen bond breaks, molecules come closer to each other. As the molecule comes closer to each other, unoccupied space decreases, volume decreases, so density rises. And this goes on till 4 degrees centigrade, at which the density of ice is maximum. Beyond this 4, on heating this liquid, again normal volume expansion takes place. As the volume expansion takes place, again density will decrease. So all the abnormal phenomenon can be explained by use of this intermolecular hydrogen bond. We say water and alcohol is miscible. So look at this, we have H2O and ROH. This is alcohol, this is water. Also we say alcohol, these are maybe CH3, this may be C2H5, etc. So look at this, we can add this. This is alcohol molecule, this is water molecule. So we have this intermolecular. This keeps on extending on the east side, on this side. Or we can also have this. the hydrogen of alcohol and oxygen of water. Again this forms intermolecular hydrogen bond. Similarly, we can have between alcohol and alcohol we can have hydrogen bond. So O ROH HOR within two alcohol molecule. Again we have this intermolecular hydrogen bond. We have this HF and HF, hydrogen fluoride and hydrogen fluoride. So again there is an ideal condition for formation of intermolecular hydrogen bond. Similarly, look at this, we can have hydrogen bond between NH3 and NH3. So look at this, nitrogen, hydrogen, hydrogen, hydrogen. You have nitrogen, hydrogen, hydrogen, ammonia, ammonia. So these hydrogen sandwiched between two nitrogen, again this forms intermolecular hydrogen bond. So this is, as I told you, this is formed between two different molecules. Acid and alcohol, RCOOH plus water. So we can have look at this, RC double bond O, this is OH. These can form hydrogen with oxygen of water, or we can also have look at this, RCOH double bond O. In both the case, hydrogen bond is formed. So this is oxygen of acid, hydrogen of acid and oxygen of water. In the second case, oxygen of acid and hydrogen of water forms intermolecular hydrogen bond. We can have look at this. Between acid molecules, we have discussing. So we have one acid molecule with another acid molecule. So hydrogen bond is formed between them. So this is intra and intermolecular hydrogen bond. Ortho nitrophenol is steam volatile because of intramolecular hydrogen bond. Volatile means the one having less boiling point. So we have look at this. So we have intra, that is ortho. Then we can look at this is ortho. Then we have meta. So in meta there is no possibility of intra, but we have inter here. So these gives an extent. Similarly, in case of para, that is NO2 and OS. So this is para isomer. Again we have inter. So when we compare the boiling points of ortho, meta and para, ortho is found to have less boiling point than, so boiling point of ortho nitrophenol is less, or we say is a volatile. The reason being we have intramolecular hydrogen bond in ortho, whereas in case of meta and para we have intermolecular hydrogen bond. So because of this having intermolecular, the number of hydrogen bond is more. So we have a large hydrogen bond to be break. So we require more amount of energy. Hence the boiling point of meta and the para isomers are more than the ortho, in which we have intramolecular hydrogen bond. So these are the types of hydrogen bond, conditions required for formation of hydrogen bond, and what is hydrogen bond. So again I am reminding, this is not actually a chemical bond. This is an interactive force involving hydrogen, which is sandwiched between two electronegative atoms. But because of this interaction, there is difference or modifications in the physical as well as the chemical properties of that hydrogen or the molecule. So since this involves specifically hydrogen, we define this as hydrogen bond. So when we compare the strength of this hydrogen bond with normal covalent bond involving hydrogen, then the strength of covalent bond will always be greater than this hydrogen bond. So hopefully you enjoy this hydrogen bond. So this is all about hydrogen bond.